Hello students, today's point of discussion is structure of sucrose. Now remember sucrose is a cane sugar or table sugar. Remember it is a disaccharide and sucrose upon hydrolysis give the mixture of glucose and fructose. Now remember sucrose sucrose is dextrorotatory but on hydrolysis but on hydrolysis it become it becomes levorotatory. Thus it is known as invert sugar. Thus it is known as invert sugar. This is very important thing to be known. Now, as far as the structure of sucrose is concerned, it consists of 1 mole of glucose, that is alpha D glucopyranose, and 1 mole of beta D fructofuranose. So what happens exactly? Carbon number 1 of alpha D glucopyranose and carbon number 2 of beta D fructofuranose get connected by means of glycosidic linkage, and that lead to the formation of what? Sucrose. Now let me explain the structural feature, I mean structure of the sucrose. Now remember, it is the pyranose ring of the glucose. So alpha D glucopyranose. So how to draw this? We are drawing the alpha ionomer. So alpha D glucopyranose can be drawn in this manner. So remember, this is the alpha D glucopyranose. Now, this is the carbon number 1. Now, we need to blend this with what? Beta D fructofuranose. So, allow me to draw the beta D fructofuranose. So, remember, this can be the beta D fructofuranose. Now, as we are drawing with beta ionomer, OH group should present on left side of the anomeric carbon. So, second carbon happens to be the anomeric carbon, CH2OH. This happens to be the first carbon, comes right here. This is the third one. This is fourth. And now this is fifth. To the fifth carbon, CH2H and H are present like this. So this is the beta D fructofuranose. This is the alpha D glucopyranose. Now remember, this is what? This is the alpha D glucopyranose ring. And this is what? This is the beta D fructofuranose ring. Now exactly what happens? Now as far as blending is concerned, now these two carbons, so carbon number 1 of alpha D glucopyranose and carbon number 2 of beta D fructofuranose get linked to one another, thereby departure of water can be seen. And now these two carbon get connected by acetal linkage or glycosidic linkage in this manner. So the structure so obtained can be drawn in this manner. So remember, this is whatever we are getting now is the structure, I mean cyclic structure of what? Sucrose. Now this is first, this is second, this is third, this is carbon number 4th, this is carbon number 5th. So now this has been connected to the carbon number 2nd. This is the second carbon, CH2OH. Now this is the fructofuranose ring. This happens to be the carbon number 3rd. This happens to be the 4th. and this is the fifth one, and this is sixth one. So remember, this is the acetyl linkage or glycosidic linkage, and this is none other than the structure of the sucrose. Now, question is exactly what is happening. So, reducible groups of alpha D glucopyranose and beta D fructofuranoate should be known. In case of alpha D glucopyranose, reducible group is present at carbon number first, and that in case of this carbon number second. So what is happening right here? Both of the groups which can show the reducing properties are engaged by are connected by means of what? Acetyl linkage or glycosidic linkage. It clearly means that in case of sucrose, there is no free reducible group. Thus, sucrose is non-reducing sugar. I mean, it is a disaccharide which do not show reducing properties. So it was all about the structure of sucrose. So connection, I mean glycosidic linkage is present in case of sucrose in between carbon number 1 of alpha D glucopyranose and carbon number 2 of beta D fructofuranoase. So it was all about the cyclic structure of sucrose. Thank you very much.